you never know. Note that when I connected 10 minutes ago, it was already recording. Just saying. So maybe that's fine.
Yeah, I started it right at the beginning when I made it. When I made the recurring invite, I think I turned on recording for when you start it. Yeah.
Oh, I see.
You know if Bao is joining today, John?
I would assume so, because he replied a couple of times recently, but I don't know.
Okay.
Everyone's schedule is probably a little weird since they're at home.
Probably.
It is indeed. So I'm so sad I couldn't join last time. I hope you had a good discussion. Was that recorded, by the way?
It was not recorded, but it was a very good discussion with Tim Menzies, I thought.
Yeah, it's one of the things that I've been fascinated by. Like,
he threw something down. He threw something down right at the end that was kind of disturbing for me, which is like, why are you guys doing testing at all? Just give it up. Can't you tell it's not working? Find another way to release software.
Yeah, I wasn't on board with quite that part of what he said, but yeah, you should definitely check out his paper on Dodge if you're thinking about doing any sort of ML type thing. I thought that was a super interesting piece of work. So
one thing, I don't know if we start, what time we start, just tell us. But one thing I've been thinking of lately is that I've sort of given up trying to measure development velocity and on different like some for data pipelines or normal backend development or client side or email, whatever. But what I'm starting to think now is that we should instead try to measure friction and how long it takes for anyone to go from a broken state to a well-working state. So if you do an ML thing and you train something and then it doesn't work, then how long does that take you to get to another model that actually works?
Well, that's kind of the same thing as the break-fix cycle, which is, I think, one of the most important measures of developer productivity.
Yeah. And I've started to do some statistics internally at Spotify, looking in what is called actually the TTR, time to repair, and seeing the distribution thereof. It's fascinating what you find there. Like it's a very good measure, a very good metric for the inverse of velocity actually.
So what was the measure again? Sorry.
TTR, time to repair.
Time to repair.
Take anything, any process, and then it breaks, and then how long does it take to get back to green?
We could have a fascinating discussion about that, but we do have our authors now. So we have
cool.
August. I see August and Olabi. Maybe they can chime in and talk us through the overview of the paper.
Hi, this is Olabi.
Hey.
Hi.
Hello.
Welcome.
Yeah, Olabi, could you or either you or August sort of give us an overview of the paper and sort of what the major conclusions were? We always like to do that right at the beginning.
Sounds good. I can give that a start. August can add to anything that I miss. So the concern in this paper is how do we check if regression test selection tools have bugs? As we are all grappling with how to speed up regression testing at different levels, more and more research is being done and coming up with different techniques and tools for doing regression test selection, which is the idea that you want to rerun tests that are affected by a change as opposed to rerunning all tests. Now, if these tools have bugs, there could be three categories of problems. They could be missing to select some tests which are affected by your changes, which refers to the safety problem, or they could be imprecise. They could be selecting way more than they need to be selecting. The third problem is they could also be less performant than simply rerunning your tests. So we want to find bugs in these test selection tools that may lead to any of these three categories of problems. Now, testing regression test selection tools can be thought of as simply testing any piece of software with two key differences. One key difference is that the test that you need in order to test a regression test selection tool, you need not just one version of a program, as other techniques have done in other domains, but you need to have a series of what we call evolving programs. So you need to have multiple versions of the same program and a set of tests that's constant among them. The second key difference then is to find bugs in these tools. One way that we approach this is, and there could be other ways, is to do more or less differential testing, where we find relative safety, relative violation, and relative efficiency problems among the tools. The key technical innovation here seems to be, as far as, one key technical innovation is, how do you automatically generate evolving programs? That's not something that was done in the literature because probably there was no need, but here we were able to do that. So the key outcomes that we were finding based on simple intuitive rules for comparing the tools based on what they select. And we came up with this set of rules. They're not exhaustive by any means. They're just a first cut approximation of what we think rules that compare these tools should have. What we're finding is that we were able to find where there were relative problems among these tools. Relative being that these rules were able to show us cases where one tool seems to be underperforming with respect to those three key criteria that I mentioned compared to other tools. And when we looked further, we found bugs. Those tools had some bugs. On the other hand, given some limitations in our study, there's room for growth here. Our rules are not exhaustive, like I said. Automatically generating tests that, evolving programs that we use to compare these programs can be done better. We only sampled a subset of the things we found. So there is need for better ways to do clustering. But overall, one of the key outcomes here is that for the first time, we're able to test a technique that is incremental across multiple program versions, using simple rules to compare output on different kinds of tests. We're able to find bugs in them that can be problematic in certain scenarios. August, did I miss anything?
No, I would say it's a good high-level summary of what we're trying to do here.
Okay, great. Thank you very much for the overview. So now, one just quick procedural note. Now that we're using Zoom, I'm going to try and pay attention to if people are clicking the raise hand button. So if you have a comment you would like to make, you can try clicking that button and or chiming in. But it might be a good way for us to get some more people involved with asking questions real time. So barring anybody having an immediate question, let's I guess start out with some of the ones that people had been asking on the doc. So let's see what the first one is. The first one is about the set of tests that the RTS developer is manually writing, and the questioner is asking whether it's reasonable to basically create a fixed set of challenging test cases and then just use that as like your static set of test cases for RTS. And whether or not you need something different than a static set. So
a static set of tests for testing these tools going for testing each tool going forward, right? Definitely one of the things that we think would be an outcome from the work that we've done is if any of the automatically generated tests or the evolving programs that we got from the two other sources, if those are considered challenging for a particular tool, if they fix a bug that we found in a particular tool, definitely we would be happy if they then incorporate that as part of the regression test suite for that particular test, for that particular RTS tool. So that's definitely a possible outcome. But I think that this same comment also mentions some limitations. You want to keep an eye out as the tool keeps evolving, as the underlying technique keeps being refined. You probably want to rerun this multiple times to see if you can find more static tests to add to your regression test suite for that particular RTS tool. So yes, this is something that can be done.
But it begs the question, could you produce a test suite like we have for Bugs4J or whatever, where you could like have several 20 evolutions and use it as a standard way to check or compare multiple RTS algorithms that you might have or that you might be comparing against. So I wonder if you think that might be something that could be possible.
It's possible. The question is, how much of this do you need, and how efficiently can you find more of this? So we thank the curators of we thank the curators of Defects4J, but then as good as that data set is, and I think there's a subsequent comment that we'll talk about that soon, it's limited. So yes, you can grab that, add that to your test suite for a particular regression test suite, a regression test selection tool. But what you do want is to consider other alternative sources of evolving programs. So yes, add the evolving programs if you want to add those, but you need to think about, on one hand, automatically generating these evolving programs as we have done. We found some bugs through that could not be found by just thinking about evolving programs. So if you want to, for example, have a unique way of evolving your programs that is not represented in the evolution history of a particular program, you do need more.
Okay, I think that makes sense. I think we do have some more questions, or at least I put some in on Defects4J and some of the other things that you're including. So why don't we pause that discussion until we get down there. Laurent, I noticed that you have the next question. I wondered if you would like to ask it.
Yeah, it has to do with the flakiness, right? If I'm not mistaken. Yes, that's what it is. And I was wondering what it would take to actually remove that assumption, which happens to be, at least in my case, not the case, let's say. I mean, in reality, so we do use RTS tools, but we do have flakiness as well. And in my experience, it's extremely hard to go below a few percent. So do you have any idea of like what it would take to, or rather, I had a suggestion maybe. What about we simulate how RTS check would work on if you were to test a perfect quote unquote RTS, but against flaky test. An idea would be to test how much it gets impacted or how much RTS check gives wrong results. You see what I mean?
If I
understand, it's about like by wrong result, you mean does it fail to select some tests that should be selected because you did not collect enough information from a past so that you couldn't like you missed some tests, or is it that I mean there's also a positive spin is that you don't select a good RTS technique should not select tests that are flaky, like they're not affected by the change. Like you don't want you want to kind of, it can be beneficial in avoiding some tests like those.
It's more
trying to get a feel for what do you mean by kind of a perfect RTS technique.
What I meant is that if you take a tool, an RTS, that is perfect, meaning that it never misses, for instance, any test that needs to be run with a change, as an example. And you introduce some flakiness in a test. My question was like, for instance, if you put a flakiness of say 1%, like 1% of the test would return red instead of green. How much would the RTS check report a bug on RTS?
Oh, I see what you mean.
I mean, this like it's kind of an open question, I realize, but given my experience with flakiness, which is like I've been fighting that for years, and it's extremely hard to go below a few percent.
Yeah.
In effect, this assumption is kind of strong.
Yeah, I guess that's because one of our oracles here, our rules, is that we're trying to compare failures. And then I guess the concept here is that some of the failures are not related to the change. They're something else altogether.
Yeah.
And you might get some you say you think your tool is not so good when comparing against like a perfect one, because it's missing some failures. But really actually they're not supposed to be failing.
Yeah.
If I understand that correctly. Yeah, I guess from just the implementation perspective, I mean, what we can do right now is sort of trying to fix the flaky tests, which is, I guess, a different angle altogether, is that I guess we have to confirm that are we actually getting the right, getting it to consistently fail. I mean, if you have this perfect RTS technique, then every test it selects must be the ones you have to select, right? So then the other guys, what matters is if any of those tests failing, if those failures are actually related to the change or not, in which case, I guess if I understand correctly, the art is sort of running it a couple of times to make sure they're consistent or not. And then you take this more like the one that I guess if you believe they're supposed to pass and you see it pass, then sort of, okay, you must get sort of the other RTS who you're comparing against must also pass. Yeah, I guess it's mainly third, how do you use these failures when they're kind of affecting the oracle we use here with the rules?
Okay, so like maybe I should have given a little bit more context, and I don't want to derail the discussion, but in my case, one thing I've done, for instance, is if you do bisect algorithm to find some commit that introduce a problem, so it's a completely different problem, but I have actually done some analysis as to how much does flakiness, I mean, if you put this 2% flakiness in your test, how often do you actually get to the right results? I can do some statistics of that sort. Like at least of today, whenever I look into any sort of tool, I always try to see how safe it is to use, given that there is flakiness. That's all. But
yes. So maybe I have a question here. So maybe like so how the result will change if we add like more flakiness here? That's here, right? So maybe the tool become like more effective in the environment that no effective flakiness is might be like not effective in the other environment.
Sorry, say that again. I didn't catch the.
So my question is like, so how the result will change if we just add consider the flakiness here? So would it be like a tool can be effective in one environment, but not like effective in the other?
One environment. So basically, one environment, you mean one where you actually have higher flakiness versus another environment which you have no flakiness or lower levels of flakiness. Yeah, no, it's interesting sort of what will happen, because I'm seeing your side like a controlled flakiness where you kind of percent of the time you make a test fail, and sort of how often do you get results where you claim one test has a bug, one tool has a bug because it's getting failures that it should not be getting, and we kind of misclassify some bugs this way.
Another thing to keep in mind is if you add the flakiness percentages into the test selection comparison, all of a sudden it may become a bit harder to compare the tools against one another. Some tools may, for example, if they statically find what the dependencies are, they may select the tests still if they're flaky. Those that are not static may miss information from the past that causes them to miss to select a test in the current version. So overall, what will happen then is the clusters of things you would need to inspect will grow as far as RTS tech is concerned, but it may not necessarily be a bug in the underlying tools. It may just be that they're limited in what they can catch when flakiness is present. And I think that's why we made this assumption, so that uniform comparison is a little bit easier.
I think what Lawrence and Bao are saying is that it's not an assumption that we can really make, because flakiness is too prevalent in the industrial context.
Yeah, I agree that
and
you don't want to.
So my question, which I'm just going to skip ahead to because of this discussion, has to do with your. Let me see if I can find it. Yeah, here he is. Your safety definitions, where you're basing your safety definition off of what other tools are selecting and off of what are the actual failures. And so I feel like what Laurent and Bao are getting at is that if you can't necessarily trust failure as a signal for effectiveness, and what are some other ideas that we could have for how to measure safety. So one thought I put in, which I know that some of the other people on this call have used in the past, is to use code coverage as a ground truth for effectiveness. So if you run the test and the changed area of the code is covered, then that is an affected test. So there may be some issues with that, especially if your code coverage isn't perfect, but it's one way of getting maybe a more truthful look at effectiveness.
Your code coverage could
so,
be flaky too, right? Sorry, just to jump in.
Yes.
Sure.
Yeah, absolutely. That's why I wasn't saying it's perfect, but we might be able to get to a better sort of definition of safetyness than just whether or not there was a failure.
Yeah, I was just going to say something maybe a bit high level so we can tease apart this discussion. So I think we need to clarify, are we talking about RTS in general, where, for example, yes, you don't want to assume that there are no failures. So an RTS technique should, by necessity, be able to deal with that. Or are we talking about comparing test selection tools among one another? So in both the coverage question and the flakiness question, I think these two things need to be separated so we can know what we're talking about. So for coverage, for example, we've talked about the flakiness question. For coverage, yes, for an RTS technique, in fact, what you described about coverage is precisely how XLZ works. So it measures affectedness by saying if a test that covers something in the old version, if what it covered in the old version changed, you do need to rerun that test in the new version. That's precisely how a tool like XLZ works. That's the core of some of these techniques. But the question then comes is, what impact do you see in terms of how this helps us compare these tools among one another? How does coverage help us in a technique like RTS check, which is not the end user's tool, but the RTS tool developer's tool?
Right, I understand that. What I was suggesting was actually something different. It's not the coverage in the old version, it's the coverage in the new version. So it's very much like retest all, except you run it with coverage so that you know which, like you know a ground truth of what was covered, modulus the non-determinism of actually measuring coverage. And I think there's also, there's non-determinism as well in the subject program that you have to consider as well, because sometimes you could get a flaky pass for a true failure. So, which adds to the complication.
Yes, yes.
Really, the ground truth is whether the failure rate is higher for the CL than at the base revision. And so we're trying to come up with metrics that estimate that, but like what we're actually talking about is this CL is making this test fail more, right?
Okay.
I think so, but it's also is the test selection technique that you're using going to enable you to define that at that particular buggy CL?
Well, it's not the selection technique so much as like the labels you're using to train it, right? Are you using good enough labels or estimating that well enough, right? And there's all kinds of ways to estimate that. You could use culprit finding, for example. If you have flaky culprit finding that can determine when which CL caused the failure rate to increase in the past, then you can use those culprits as your ones and everything else as zeros, for example.
Well, in the context of this, they're running at every CL, which in non-Google terms means every change. So they basically run their RTS tool, or tools in this case, at every single change that was made. And so then they're evaluating which RTS selection tool is selecting the tests the best in terms of safety, precision, and generality. Did I summarize that correct, August? Or
Yeah, it's fair, but I would just point out that what we're doing here is to compare the tools. You're right about our definition of safety. You mentioned that, and that's a fair comment. Perhaps we should think more in terms of relative safety. The way we looked at it in this particular piece of work is that if a tool is really relatively unsafe compared to others on a CL, then there is likely something wrong in that tool.
And that makes sense. I agree with that. Okay, let's move on from the safety discussion for the moment. Let's see what other questions we have. Bao, I see you have a question here. Do you want to ask it live?
Sure. So basically, this tool we are using like the AutoGen test generator, right? But in practice, we don't have that tool. So we mostly like leverage the existing tool, test pool for that, right? So what do you think? What is the difference between like using the like existing test pool versus like using the test generation full tool here? Is it clear?
I think the test generation tool here is mainly used in the point where it's actually in conjunction with generating programs. So it's not even sort of an existing code that we're trying to test and we generate tests for it, but rather we're generating whole new programs that don't even have tests with it. And that's where the auto generation test generation tool comes in. It's sort of combined with the program generation as well. If you had existing code, which I guess is another kind of what do we call it? That's the other component where we use existing code. Those, I guess we use existing tests in those cases, and we run selection tools on those. But the generation tool itself, I think we were mainly using it just for the sake of when we don't have tests to begin with. Is that what you were asking about, or?
Yeah, that's what I'm asking, because in practice we don't have that tool. We don't use that generation tool, and we already have something already there. Like it's a different like from the research like setup, right? When you don't have the test, right? Yeah.
Yeah. So I think if you have tests and you have existing code that you're trying to test, you would rather run the RTS tools on those to see how it's going on this code. In these cases, I guess it's not just the fact that we don't have tests, but we don't even have code. We're trying to make the code that's sort of interesting for these tools. So that's why we also have to generate tests to go with it. So that everything is kind of from scratch for this component.
Right. So then, what do you think? Is there any difference between the two approach? Like if you like, yeah, go ahead.
So I think the main difference here is that we're exploring code that maybe people don't write, but it's something that if it's like within the bounds of this language, these tools should be able to handle. So you might not necessarily find this. If you search enough code, you'll probably find these cases. But sort of we don't have to spend that time looking for all the code. We're going to try to generate some of the more interesting cases kind of we know about. I mean, see how these tools react on these cases.
Okay. All right. Yeah, I think my second question already answered like before. Yeah, we already discussed that. Yeah, about the code coverage. Right.
Yeah, maybe I can scroll down for a second, because I thought this table 7 and their results, they did using I forget which one it is. Is it called AutoEP? I believe that's the one that does the program and test case generation. It was able to find violations of for I guess mostly for the Clover tool, but there were some bugs that it actually identified in that tool.
Yes, it found the auto generation found bugs in Clover and Start as well.
Oh, and Start as well. Okay, I missed that when I was just doing a quick scan. Okay. and and you have basically two types of bugs that you found. You had the implementation bugs where they were not necessarily limitations of how of the general technique the tool is using, and then you had technique limitations. So you had sort of like bugs that were sort of real bugs that, like, you know, were mistakes in the code, and then bugs that were not so much bugs but limitations of the way they were doing things. Is that correct?
Yes, that's
Yeah.
correct. And those technique limitations are also important because as an RTS tool developer, you may not know all the limitations that your technique has a priori. So helping you find those limitations this way also could be valuable.
Yes. And so I think, Bao, when I'm looking at this chart, you know, some of the things in here, such as using a class with instance of operator is not captured, that sort of highlights the usefulness of this type of technique for the tool developer, where you're getting kind of a sort of a specific combination of language features that maybe are less frequently appearing in your like a Defects4j or even in your sort of production code.
Yeah.
Yeah. But I feel like point taken for me on what you were saying, because I also had questions about you know, the definitions of some of these things, of some of these properties when both the programs and the tests and the oracles for the tests are all being generated. All right, let's scroll down to the next question. Okay, so we talked about code coverage, and then I think most of my questions we kind of talked about already. They were talking about safety, and I'm going to skip them for the moment, but maybe we can just talk about the three ways of doing things. So they had three different approaches for making data sets. They had their auto EP approach, which constructed random programs using a program generator, and then random test cases using randup, which constructs sequence of method calls. And then they constructed, their assertions were done through state capture of the first version of the program that they generated. And their second approach was to use Defects4j with using the buggy and fixed revisions to simulate program change. And then their last one was using program evolution. Actually, I can't remember what they were evolving in this case, but they were using a program evolution tool. Can you explain how you were doing the evolution?
For this last one, it's less of we were making evolution, but rather we're using kind of real evolution that you see in like you take an existing code base and see how people are actually making changes.
Okay.
So evolution is sort of manual evolution that's been done in the past. So there's typically, I guess, bigger or more specific to certain projects, but seeing what people are actually doing.
Okay. Okay. Sounds good. Yes. Sorry, I wasn't as familiar with that one. Okay. And here we have another question, but before we do, I was wondering if anybody has any questions or comments about the ways they were generating their data sets we haven't asked already. I will say that although we have, you know, like I think each one of these approaches sort of has its issue. They all have sort of different issues. For instance, the current thing that people are saying about Defects4j is that we're overfitting to Defects4j, and in this case, they're sort of mitigating that by using other sources of data as well. The criticism of generating programs or test cases is that they're not realistic, but we're mitigating that by using real programs. The criticism of using just a couple of versions is that it doesn't represent overall evolution. So they're sort of attempting to mitigate the criticism of each data set by having a different data set that doesn't have that problem, but unfortunately has some different issues. Okay, so Here's this question. It says, are the generated test cases generated deterministically? Can you say whether or not they're deterministic test cases that you're generating?
So the process of generating them, it's possible that on different runs, given different seeds that you start with, you may get different programs. But given the same seeds, I think that you will get the same programs. We also do note in the paper that the programs themselves, given the current evolution operators that we use to take an initial version to a next version, given how limited they don't generate tests that are, programs and tests that are flaky. I think that's in the discussion section, if you want to scroll down. So that's currently just because of the limited, how small we deliberately kept the generation, the range of things you can generate and the range of programs you can generate. You will not get programs that are flaky. But I think that the generation process, given same seeds and same initial configurations, I think for the auto EP, that is deterministic by itself. Does that sort of answer the question?
I think so.
Yes, thank you.
Okay. Good. So, I mean, are we done with that
Sorry,
question?
I think I was muted. I apologize. I was just reading this question. Have you considered building automatic test case minimization or clustering for the violations?
So if Jiri is on the call, maybe he can say what he was thinking about the minimization part. What part are we thinking about minimizing? For clustering, yes, actually that's, if you look in the future work section, that's one of the things that we clearly stated that needs to be done in the future. We need better ways to cluster. But the minimization part, I just want to be clear what exactly was the thought before I say something about that.
Okay, can you hear me?
Yes.
Thank you. So when you are inspecting the result, you want to see if it is a bug in the tool that you are testing or not. So if the program is small, it will be easier to inspect it manually. So if you can have automated procedure, which will make the program shorter while keeping its properties intact, it will be easier to look at by hand. That was my idea.
That makes a lot of sense. I think we haven't started looking into that, but it's definitely something that we could consider going forward as well. I would say though that the auto EP programs are generally very small. So maybe this is something that applies to the other two components. But yes, your point is valid. I agree with that.
Yeah, thanks, because I have some experience with fuzzing errors, and there the minimization is very, very helpful. So yeah, thank you.
I think something very interesting thing to do here is, because minimization now is not just like the input is kind of like two programs almost, right? So you want to minimize, like if you have some big Evo EP kind of program from like say, so some existing code that's large, sort of how do you minimize the two versions? How do you minimize the change to some way to actually expose the same bug? I think that's a very interesting, like just like things to consider. Like how do you even develop a technique that sort of takes two programs and like two program versions evolution account to minimize that altogether? Yeah, something we haven't considered per se directly, but it sounds very cool.
So just one thing to note is, I mean, I think the idea is very interesting, but at the same time, like, you know, for the bugs at least that we encountered, we had no hard time to actually locate and kind of, you know, find where the bugs are. Maybe because we developed 2 of the tools, and we actually did not even attempt to debug the Clover, which was developed by someone else. So maybe if we started digging into the tool that we did not develop, maybe it would be very useful. For us, for the bugs we found for Ecstasy and Starts, it was mostly straightforward once when we saw basically the original and the change version.
Okay, that sounds good. Did that answer your question, Jerry?
Yeah, thanks.
Okay, great. All right. Let's see what, I think we maybe had another one down here by Laurent. It says none of the bugs detected by RTS checks were detected by mutation testing, providing an initial evidence that the mutants generated by traditional mutation testing does not help expose bugs in RTS tools. And I think Laurent was wondering why in general, but maybe Laurent, you can unmute and let us know exactly what your question.
Yeah, so I found this very interesting. Actually, I was really wondering, like, in what way those mutation testing tools differ from the changes that we see for real. You see what I mean? Like mutation testing, it's somehow, in some way, it introduces, well, it doesn't introduce bug per se, but well, it introduces mutation, which most likely will create regressions in tests, or should actually. So why, like, in what way those changes differ from the changes that RTS tools are supposed to capture? I was, yeah, I don't really have an answer for that, but I was really wondering in what way they would conceptually differ. Does that make sense?
Yes, I think that's a great question. So I think August probably should take this one because he was the one looking closer at that experiment. But kind of, briefly, it's just kind of, our conclusion was that those changes are maybe at least those that were in PIT, kind of this mutation testing tool, maybe they were just kind of, too obvious. Namely, they always change something that RTS is going to capture, basically all those changes that happen inside bodies of some methods.
Yes.
And those are kind of, I think because we are using like, just existing checksums to compute the checksum of all the methods, we just did not expect any problem there. If the mutants were more complex, like, shuffling things across the methods or classes, maybe we would expect more, but these sole changes, like just being always within the methods, were just like so simple. They just probably, that's the main reason. Again, August can probably say more.
Yeah, I mean, and generally it's what Milo was saying, sort of the kind of these traditional operators like the changing plus to minus or moving some metric calls and stuff. They are, again, relatively simple, but for the sake of like kind of testing the tests, they're kind of useful there. But for these cases, for the RTS tools, they're much more complicated. And you see some of the operators we do for the optimal evolution, they do some kind of really more funky things, kind of more specific to the Java language. That sort of are kind of from our experience as maybe as developers of these tools, that sort of are the trickier things to consider. And so, I mean, maybe another question is sort of, can we take these evolution operators and put them back into mutation testing to see how effective we can see if tests are capturing these things? Could be interesting as well, but the existing kind of traditional testing operators are just not comprehensive enough for these testing tools, for these RTS tools.
Yeah, so we're looking at two totally different classes of changes in a code, really.
Right. And then, yeah, maybe cool just to see if we can take these evolution operators we said for RTS check and use them as kind of for mutation testing purpose itself to see if tests are like say killing these mutants or not. Yeah, I think that'd be pretty cool to see sort of how good are these as mutation operators.
Yeah.
I mean, it is a pretty unique testing scenario because there's obviously the impacts of language feature complexity, which is more of like a compiler testing sort of problem. But there's also, but when you pair it with the evolution is sort of different, and having the real data, I feel like it's quite different than the normal sort of testing situation. That said, I don't think this technique would necessarily be good for every RTS algorithms. For instance, the ones that rely more on like code or bug metrics. I'm not sure that this particular, like especially the auto-generated stuff, and even the randomly or the defects for J set would really be that helpful. But I feel like it's definitely good for people who are working on those kind of systems to sort of like think about what's the best way to evaluate and compare to some of these other more, I guess, fine-grained selection methods.
Yeah, I think that's also.
No, go ahead, please.
Go ahead. No, I just want to add that. Sorry, go ahead.
Yeah, maybe. So I was commenting more sort of what other RTS techniques do you have in mind here? Sort of are you talking about like ones that you based on like history, the select tests that sort of fail more often? Like, are you talking about techniques like those, where you maybe it's not based on structure of code or things like that?
Yeah, I'm talking about ones that are based on a combination of history and code metrics, like for instance, we've talked in the past about in this group with like the Facebook's recent paper from ICSI that was on their they're all heuristic code metrics based, and I think we had one more in this group about that, and Google has done some work as well. And essentially, the companies that are doing this work are doing it because code coverage techniques don't scale, analysis techniques don't scale to the amount of code or the complexity of our situation with the number of languages we're supporting. So, and also we're not scheduling methods, we're scheduling large test suites as our unit of scheduling granularity. So when looking at things like dependencies, we're talking about build dependencies, not like class or method level dependencies.
Right. Yeah, I suspect in these cases, maybe the auto part that which might generate program elements and changes may not be so helpful with these techniques, just because like the techniques are not based on like code structure, right? Like they're based off of like your heuristics, historic information and such. You probably would need either generate like a lot of programs and then get like a lot of evolution and see if you can train on that, though you may not get necessarily many failures, which I assume a lot of these metrics are based on as well. And then you might need to actually then make a data set using the other techniques where you actually have failing tests or actually have like bigger evolution changes, and maybe more specifically the kind of project you want to learn on to see sort of how to maybe evaluate these techniques on each other.
Yeah, and it probably, I feel like at least in our case, we would be using, historical data as sort of our test set, which may be problematic, but we would get a ground truth when we would then run the algorithm. But when you're thinking about bringing a new algorithm online, how to compare it with the old one, what metrics to really look at, I feel like, some of the ones that you present in this paper are good ways to measure the safety and precision.
Yeah, I think it's pretty challenging for like researcher, right? Because they don't have the data available. That is one problem. Yeah.
Yes, absolutely.
Yeah,
So
if you give us access to Google Code and all the data you have, you're gonna come up with something. On a serious note, yeah, we did actually discuss that. I forgot by now, like, if we actually have that in the paper or not. But we discussed that, when we worked on this project, if it would apply or not, because around the same time when we worked on this project, we saw also that paper from Facebook that was presented at FSC in fall 2018. So then we discussed and thought, but as you said, like, some of these techniques simply were not designed for the cases when you need some historical data or when you need to look at some metadata. For example, it will be very hard, I mean, possible, but probably hard to generate all the metadata that some techniques use, like, who are the developers that are committing, right? Or, what time of the day it was, or just of course, you can always generate and generate as long history as you want, using, for example, even auto EP that we have. It's just the question, like, does it include really any realistic data and close data to what you may find or care about? And it just becomes very complex. Plus, it's you were saying we don't have access to some good data set, so we kind of just did not look further into that.
Right. And unfortunately, I think it would be hard for any of the companies to release a perfectly useful data set for training an algorithm like this. Although, Bao, Google did. You were involved with a release from Google when you were with Google, correct? On a data set. And John,
Yes.
you were
Yes.
with that as well.
Yeah, and we released a data set, but it wasn't a reproducible process, and it was super hard to do because they wanted us to sanitize the hell out of everything. We had to delete entire areas of the code base that they didn't want to even release metadata about, even if it was anonymized. It was very strange. So I don't know that we arrived at a reproducible process, and the whole process did about, I don't know, 8 or 9 or 10 or 12 iterations before we got to something that the people would let us release. It's really hard to release reasonable data, although we do have a good data set that was out there for that paper.
Yeah, but another way is you can rely on the open source project, right? They also have some test data too. Yeah. So it's interesting to compare between the one which is already there and versus the one generated by the tool. Yeah.
Yeah, I mean, one problem is certainly data set, and I know that the data set Sean is describing, but I believe none of that stuff can be run outside, right? I mean, the only thing that's released was the names of the test and pass and fail information,
Right.
which again.
We didn't even release the names of the tests. It's only completely anonymized that there is a test and it's got this weird string for the name.
Sure, okay, let's call it test ID, yes. And we just did not find it appropriate for this particular study or checking for the RTS technique. And another problem besides dataset, of course, is the availability of the technique, right? We don't know any open source technique that uses this metadata and uses something like Facebook tool that they described that we learn from the past history. There were a couple of research papers, but they did not release any tools either. That means we would need to reproduce and rebuild the entire tool first. Then to find and build the entire data set and then go and evaluate. Again, I'm not saying this is not worth doing. It's not worth a research paper, but just saying it would be a lot of effort.
Well, and I mean, there's the other problem with, Facebook, like Google, is kind of a mono repo, a little bit less true than Google, but, in comparison to companies and open source world where dependencies are versioned, everything is built ahead in one repository, and dependencies are represented using Bazel, or Facebook wrote their own tool, but a Bazel build graph. And that's just, there's a handful of companies that have seriously adopted an approach like that, but it's not generally applicable. And so when you're thinking about RTS and you're thinking about dependencies outside of that sort of specialized situation of these large companies, maybe you have to think about it as version dependencies and what RTS looks like when you're trying to upgrade them. I'm not sure. I haven't thought deeply about this issue.
No, yeah, that's a great point. I think Kovalabi in August, if I remember, had a paper on trying to recreate Google scale or Google-like scale, set of projects that's available in open source by connecting them through the dependencies. So that means, let's say you have a project P1 that depends on P2. And of course, in open source, very likely, as you said, P1 depends on P2, a certain version of a jar file. So what they tried to look at, like, what if this was actually depending on the current version at the same time when this, P1 was being built? What is the current version of P2, and then trying to build it that way? And by kind of, looking at the entire stuff that's available in the open source, you can probably build like, much larger graph and much larger data set than even Google may have. But, of course, it just requires a lot of engineering, plus it's...
It would never compile.
Very likely.
The head state of 10 dependent open source projects is not going to be compilable, because whenever you pull in the new version of the open source, that's when you do the tax of trying to figure out what you need to do to make it compile in your latest project, right? So I think unfortunately even that technique won't solve the problem because of the work that would be required at each change to make it work.
Yeah.
That said, the version update problem is a real problem that a lot of companies are struggling with and do not have good solutions. So testing techniques to make that safer.
I've seen it both ways, Tim. I've seen it where people aren't using a monorepo and they pull in the new version and it adds, and they have to do a lot of work. And then at Google, where we were using the monorepo, whenever we pulled in a new version, it was like a crusade by someone to find all of the referencing Google code and fix it. So it was like, it's hard work on either end of the consuming open source bits is hard work on either end of the spectrum, whether you have a monorepo or whether you're consuming the binaries.
I've also heard it's difficult when you're internally versioned, though, that, like you have, internal library X and it's widely used and it has different versions and everybody's pinned, and the upgrades are difficult for there as well. So yeah, doing the versioned upgrades is a real problem, and I don't think anybody has a good solution for it right now.
Yeah.
All right, does anybody have some closing comments that they would like to make about regression test selection or about this paper? I think it's a great paper, and I want to thank the authors for coming and taking the time out to talk to us about it.
Yes, thanks a lot.
Yeah, thank you.
Thank you so much.
Oh yeah, of course. Thanks. Thanks for the invitation. Yes,
Thanks, guys. Yeah.
Yeah, we definitely all find this to be an important problem, and I like the paper. I think it's really interesting. I think that more work like this, where we look back at better ways of evaluating techniques, are really great contributions. So thank you.
Okay,
Agreed.
Okay, thanks for the call.
Do we have a paper chosen yet, John, for next month to announce? I don't think we do.
I don't think we do.
Yeah, we don't
Okay.
yet.
All right, we will work on selecting one, and our current update on our workshop that we were going to hold at ICST before COVID-19 became a reality is that it is going to happen in October, assuming ICST happens in October.
Wow, I sure hope by then we can travel again. It would be nice to get out of my house.
Yeah, just hope we don't have a second wave of it, but yeah.
Yeah. So we're just going to hold our plans lightly. All right. Thank you, everybody.
All right. Thank you, everyone. Bye.
Bye-bye.